Up next, we have Shafeeque and Sonu Kumar Singh, both key contributors to the open source Gardener project at SAP. Shafeeque is a mechanical engineer who's turned into a software developer from IIT Guwahati. He is passionate about building scalable and secure systems. Sonu, with a strong background in cloud native technologies, is dedicated to enhancing Kubernetes cluster management. Today, they both will share insights on how they host homogeneous scalable Kubernetes control panels across multiple cloud providers using Gardener. So let's give them a warm welcome.
Good morning, everyone. So today, Sonu and I would be presenting our project Gardener. So we provide homogeneous Kubernetes clusters at scale across all major cloud providers and also data operations with minimal TCO. So how many of you folks have heard about Kubernetes? Oh, that's quite a lot. Okay, so for those who don't know, so Kubernetes is a container orchestrator. So it has become the de facto standard for the same for quite some time now. And it's used widely to run cloud native workloads. So let's just see a small overview. So Kubernetes basically uses reconciliations which acts on these observe, analyze, act loops. So they observe the state of the system and then they work towards achieving a desired state. Also, we have two planes. One is the control plane, which has all the control components. So for example, we have the Kube server, which is the central entry point to the cluster. Then we have HCD, which is a highly available key value store, or it's the database for Kubernetes. Then we have some controllers which work together to achieve the desired state. Then we have the data plane where the actual workload runs from the user. So we have some components there, kubelet, kubeproxy, etc. So as a user, so if I want to get something, so who do I talk to? So I talk to Gru, or in this case, it's the Kube server, which is running in the control plane. But when we ask something, so Kube server does not work for itself to achieve it. So it will delegate the work to the minions. So in this case, the minions are the data plane. So yeah, so the user just declares the desired state, and then yeah, all the controllers work together to achieve it. So about managing Kubernetes. So it's easy to deploy an application in Kubernetes, but it's just the tip of the iceberg. So what goes on underneath it? A lot of things. So operating Kubernetes can be quite challenging. So once you start using it, you will quickly realize that it's just not about deploying containers. There are numerous other components to manage, like networking, observability, then there are resource allocation, auto scaling, and much more. So it might not be very straightforward as it might initially seem. So and this complexity isn't very scalable, and especially when many teams within an organization want to run Kubernetes and they want to use different cloud providers, let's say AWS, GCP, Azure, etc. And they also want to run different OS, they want to use different networking plugins. So then it can be tough. So we need to know their intricate details, their command lines. We need to learn a lot of things. So also, let's say you want to deploy Kube server. We have a lot of flags in it. It's not visible much. But yeah, we have a lot of flags that we need to be familiar with. Then let's say kube controller manager, similarly kube scheduler, and the list goes on and on. So and misconfiguring any of these can lead to issues which can affect the whole cluster, and it can be quite challenging to maintain a secure environment. So then how do we deal with this? So we have to go for a managed Kubernetes service. So then we were left with two choices. So either choose an existing managed Kubernetes service like EKS or GKE, or then and then we had to face the limitations which come with them, and we also had to pay them tons of money. Or we can build our own solution, and which will cater to all our needs, which is homogeneous across cloud providers, and we should be very scalable. It should be self-healing, meaning we don't need to micromanage it. and also it should be cheap. So guess which pill we chose. So we decided to build our own solution. And where did that take us? As of today, we are running with more than 7,500 clusters, which uses over 50,000 nodes or virtual machines, and uses over 700,000 CPUs and close to 5 petabytes of memory. But how exactly did we achieve this? The answer is Kubeception. We use Kubernetes to manage Kubernetes. But how exactly does this work, you may ask? So as explained before, we have a control plane and a data plane. In this case, in Gardener, the control planes of different clusters, different child clusters, run as pods in the parent cluster, as seen here. So they are just workloads for the parent cluster, and the example, the Kube API server, etcd, all the controllers, everything run in the parent cluster. So in a normal case, a control plane would need separate VMs for each of the cluster, child cluster, but in our case, this parent cluster is shared between them. And let's also look at some terminologies. So in Gardener, we have this garden cluster, which is the resource meta cluster, which holds all the custom resource, which is managed by Gardener. Then we have the seed cluster, which is the parent cluster that I talked about. So all the control planes are hosted in the seed cluster. Then we have the shoot cluster, which is the cluster provision for the user. So all the nodes will be running in the user's infrastructure account, so they have to bring their own infrastructure secret. And also we use similar Kubernetes terminology. So in place of Kube API server, not in place, in addition to Kube API server, in Gardener we have Gardener API server, then Gardener controller manager for Kube controller manager, scheduler, then we have a component called Gardenlet. So in Kubernetes, a kubelet runs in the node and it manages the pods. So in Gardener, we have Gardenlet running in the seed and it manages multiple shoots. So we can have seeds for different infrastructure and different regions, and then it can host the control planes of multiple shoots. And also Kubernetes have the CLI tool kubectl, and we have GardenCTL. But what is a shoot? So shoot is a Kubernetes custom resource which contains the configuration for all the things that the user might need and they need to know to get the cluster they want. So be it provider related, OS, networking, and whatnot. So every configuration is present at one place, and this is the same across all the cloud providers. So and also all OS, all networking plugins. So the shoot YAML does not change. So you need to learn only this, and you are ready to get a cluster with any supported infrastructure and any OS or any network plugin and so on. And let's also talk about extensibility. So Gardener is extensible by design. So this extension concept is an out-of-tree architecture that keeps the Gardener core logic independent of provider knowledge or networking plugins and OS, etc. So this is similar to what Kubernetes have achieved with out-of-tree cloud providers or with CSI volume plugins. So for example, during shoot creation, Gardener creates a infrastructure resource which will be reconciled by its respective controller, and similarly for network, OS, container runtime, etc. So if one needs to extend this, so they can write their own set of extensions to support a new cloud provider, and they don't need to touch the core code base. And this is also a way to contribute back to the community. And in Gardener, we also have more in-house components that are designed to work particularly with Gardener, but that can also, that is part of every hosted control plane, but that can also run independently outside Gardener. So we have Garden Linux, which is a Debian derivative, and it has a lot of customization features. And then we have etcd Druid, which is an operator used to configure, provision, reconcile, and monitor etcd clusters. Then we have the machine controller manager, which provides a uniform Kubernetes API to manage the lifecycle of machines across cloud providers. And we'll move on to the features of Gardener. So I'll hand over to Sonu.
Hey everybody. So I'll talk about some of the key feature of the Gardener, which Gardener provide. So starting with first one is the hibernation. The idea is at some point of time you don't need your cluster, for example, on weekends. Or if you're a developer, you don't need your cluster during your off work hours. So you can simply send your cluster to hibernation. What basically means is when you hibernate a cluster, all the VMs will be deleted and a control plane will be shut down. So this will save a lot of money because the main thing which costs the money for a cluster is virtual machines that will be deleted and shut down. Next feature is high availability. In general, in Kubernetes cluster, you will have only one replica for all the control plane components like etcds, QAPI server, and others. This can lead to downtime in certain scenarios. For example, if a node get deleted or a zone goes down. So if a node get deleted, the etcd running on that particular pod will get deleted and it need to come back on some new node. So it will take some time and this will cause a downtime. And for the zone case, there are certain cases in the past where whole cloud provider zone goes down. In that case, the workload running in that particular zone will face downtime until the zone is back. To deal with this issue, we offer high availability. So in place of one node, we run three replicas for etcd and QAPI server, and all other components will run in active passive mode. We offer two kind of HA configuration. One is node, the other one is zone. So in node HA configuration, what we'll have, like all the replicas will be span over multiple nodes. So if a node is getting rolled, you'll not face a downtime because the other replicas will be there to serve the request. In case of zone HA configuration, high availability configuration, what will happen, the pods or replicas will span over multiple nodes, and specifically those nodes will be spanning over multiple zones of a particular cloud provider. So what will happen, even if the zone goes down, other replica will be there present in other zones to serve the request. Next feature is control plane migration. So when the organization grows, there are certain use cases. There are certain scenarios where, because of the business use case, people like or one would like to move their control plane from one location, one cloud provider region to another cloud provider region for providing better latency and other reasons. To serve this feature, we offer control plane migration. So one can migrate their control plane from one cloud provider region to another cloud provider region without the need of deleting and recreating the cluster, and without affecting the workload of the users. Next up is disaster recovery. Gartner supports backup and restore of etcd. We have an in-house component called etcd backup restore component, which backs up the data of etcd backing the shoot cluster regularly. And in case of disaster, where all the data is get lost for whatever reason, you can just recover the etcd using that backup. Next up is workerless cluster. So in this case, you'll see there are no minions, that is, there are no worker nodes in your cluster. So there are certain scenarios, use cases where you need a cluster which does not have any node. You only need the features of control plane. So in Gartner, we can create so-called workerless shoots, which are exactly that kind of Kubernetes cluster, which does not have nodes and it only has control plane. Up next is credential rotation. This is one of the key features which is offered by Gartner. And what I know so far, any major managed Kubernetes service provide this feature. So in a Kubernetes cluster, you'll have multiple secrets or multiple secrets. For example, kubeconfig, CAs, observability password, and some others. The thing is, for compliance reason, you have to regularly rotate them, and for security reasons also you have to regularly rotate them. Doing this manually, one by one, or doing is very tedious and cumbersome task. In Gartner, you don't need any of those things because, and you can just simply rotate the credential with only a set of annotation. Apart from the feature mentioned, we have another set of a lot of features like auto scaling of cluster, where cluster size can increase or decrease based on the requirement or the workload. We offer maintenance window, so shoot can configure a maintenance window, and Gardener will apply some of the changes to your cluster during that maintenance time window. And also some of the things can be configured to update in the cluster, which will be happen only during the maintenance time window. We also offer automatic OS and Kubernetes version upgrade. So if configured in the chute, during the maintenance time window, Gardener will automatically update your OS versions and Kubernetes patch versions. So we are back to demo time. We'll head over to the Gardener dashboard. So this is how Gardener dashboard looks like for Kubernetes clusters. So here is a list of the projects. In the Gardener, we separate Kubernetes cluster with projects. So in an organization, a person or a team can create a project, and all of their clusters will be residing in this particular project. So if you see, I have created a project called FOSS for this particular demo, and I already have two clusters running, cluster 1 and cluster 2. I'll go on and I'll show how easy it is to create a cluster using Gardener. You just click on the create button. As of now, everything is running locally, so you see only one infrastructure, which is local. In the actual scenario, you'll see multiple things like AWS, GCP, Azure, and others. For cluster name, up next is a cluster name. I will name it FOSS 2024. Then after that, you can select Kubernetes version from available list of Kubernetes version. 1.30, I will select the latest version. Then the purpose of the cluster, you are going to use it for development purpose, production, or whatsoever. So I'll select the evaluation. Then there is workerless cluster, the clusters without the nodes. I'll not check. As of now, I'll create the cluster with nodes. Infrastructure details, it's one of the important things. So if you see there is a secret, it's a secret which is provided by the user, and all the infrastructure resources like VMs and other things will be created in this user account. Then you select the regions from the available set of regions on the cloud provider, networking type, Calico, Cilium, then HA configuration for like node and zone HA configuration, some other thing. And then in the workers. So in the worker are basically the nodes of your Kubernetes cluster. You can select the architecture type of your nodes, which is AMD, ARM64. Then machine types, it will be there available based on the machine present in that particular cloud provider. Machine image, the container runtime like containerd, Docker. Then this is autoscaler min and max. So min is the minimum number of nodes which need to be present at any point of time in the cluster, and max is the number of node which will your cluster can scale up. Then few of the add-on features are there like dashboard, Nginx ingress. Upcoming up is the maintenance window. It's a window in which Gardener performs certain update on the cluster. You can also select automatic update of the operating system in the Kubernetes version in your cluster. And if selected, during the maintenance time window, Gardener will automatically update these things in your cluster. Up next is hibernation. So you select the hibernation schedule according to your needs. So if you're a developer, ideally, I guess you would be checking out at 5 p.m. So you can just select your cluster will get hibernated every day after 5 p.m. And then you go in and hit the create button. Yep. And your cluster is ready. So I'll summarize it with this slide. With Gardener, creating Kubernetes cluster is as simple as this. You don't need any special requirement, equipment or gear to use Kubernetes. Just few set of clicks, and we'll give you a production-ready Kubernetes cluster. Coming back to the slides again, I will show you the cluster which we have created. Everything will, at the end of the day, will translate to a YAMLs, and you can see there are things like Kubernetes configuration, your hibernation schedule, the nodes configuration, like CRI and whatnot. Everything will come down to this stuff. Also, in the dashboard, there are tiles for cluster, which shows the readiness and health of the cluster, like this API, control plane, nodes. So it shows like if your QAPI server is ready or not. Your control plane components are ready or not, your nodes are ready or not. All of this can be checked through this. Also, we have our in-house tool called Garden Cuttle, which can be used to target the cluster and their control plane I will go on and target one of the cluster, which I have already created the cluster one. You can just check this thing, and yeah. Type this, and yeah, we have targeted the cube. As of now, the cluster one. I will go and list the namespaces in this cluster. And if you check, this is the plain vanilla Kubernetes cluster. When you use Gardener, you get a plain vanilla Kubernetes cluster. There are certain set of pods which we create in the kube system namespace. Yeah. So Gardener creates certain set of pods in the kube system namespace to support the Kubernetes cluster. And similar to targeting the cluster, you can also target the control plane of this Kubernetes cluster using same Garden Cuttle tool. And when we target, we have targeted the control plane of the cluster. This is a whole set of different Kubernetes cluster, and everything of the cluster which you're seeing will all the control plane components will be running in some other Kubernetes cluster as a native Kubernetes workload. So I will go on and list the pods. Yeah, and there are all the pods which you see in general for a Kubernetes control plane, like etcd is there, kube server is there, kube controller manager, and kube scheduler, and other stuff. I'll come back to the slides again. So, yeah. So in summary, what is Gardener? So Gardener is homogeneous. It provides identical day one and day two operation across cloud provider. It's open source grown. Gardener is developed in public, pioneered by SAP. And all the projects under Gardener comes under Apache license. It's ultra scalable. As you have seen, we have already scaled the number of cluster in SAP to 7,000 and more. You can use Gardener to scale your Kubernetes clusters with manage thousands of clusters with minimal TCO. We are 100% compliant, Kubernetes compliant. It provides same experience across cloud provider, be it AWS, GCP, Azure, or Ali Cloud, and others. It provides self-healing capability. So with time, it provides self-healing capability. So everything in the Gardener runs as a native Kubernetes workload. So if anything goes down, it will come back on itself. Sorry. So this is how cloud native ecosystem look like. There are multiple things like container runtime, registries, databases, and all. And Gardener stands right here, which you see. It's a platform which provides 100% certified Kubernetes installation. So who else is using Gardener? Apart from SAP, there are multiple adopters of Gardener. Yeah, like StackIt, Metal Stack Cloud, and some others. So to learn more about Gardener, you can join our community. You can join our Slack group and follow us on GitHub and other platform. And thank you. You can scan this code to learn more about Gardener. And we are now open for questions.
So I have a question related to the auto scaling. Then when you were creating the cluster, so you're providing the auto scaling parameters, right? Is there a way we can also include based on custom metrics like TPS or based on CPU when it throttle, then the pods get auto scale. Is there a way in the
You're asking about pod get auto scaled or number of nodes. So what you see that auto scaling is about the number of nodes. So you set a minimum number of minimum nodes. So when the workloads are less, overall request is less, it will have the number of nodes, and accordingly, and the max number of node is the number of nodes. So when the workload increases in the cluster can scale up to that certain number of nodes only. So it's needed for the cost. Otherwise, you can scale your Kubernetes to infinity and number of nodes. So that's why there is a minimum and maximum. So at what is the maximum of nodes which you want at any point of time in a cluster?
Yeah, but there is a way to customize, like custom way of scaling based on the Prometheus query. Based on the Prometheus query, you can provide the custom query.
So we use cluster autoscaler, which is used to scale the number of nodes based on the request.
Okay.